Lesson 10, last lesson for the summer. We've still got the review to go over the top 10 things, but for the notes, we're done. We got up to the practice before and I stopped and said I didn't want you to have to watch me write, so I've got the two practices coming up ready to go. This is Ionic nomenclature. You're going to be thinking about charges, you're going to be thinking about ion names, and if anions specifically are polyatomic, like sulfate, sulfite, or monatomic, sulfide. So let's see what we've got. Lithium is +1 or 1 plus, and sulfate, polyatomic ion with the ATE ending, 2 minus. I need 2 lithiums, 1 sulfate. Remember, if I needed more than 1 sulfate, it'd have to be in parentheses. Oxalate, ATE, polyatomic ion. It's not one we usually use, so I look it up. I see that it's 2 minus. Calcium's in group 2, so it's 2 plus. There's calcium, knew that one, and oxalate, C2O4. Again, if I needed more than one, I'd put it in parentheses. Potassium nitride, IDE ending straight from the periodic table, group 15, so 3 minus. 1 plus for potassium, K, 3, N. 3 of those, 1 of that. Silver nitrate, nitrate. I might expect silver to need a Roman numeral, but I remember it's one of the exceptions, and it's always 1 plus. Nitrate, on my ion sheet, or I remember it, it's pretty common, 1 minus, so Ag, NO3. Ammonium, pretty commonly forgotten. It looks like it should be an element on the periodic table because of IUM, but it's polyatomic. So is hydroxide. Find them. NH4OH, just one of each. Copper 1 chloride. My Roman numeral tells me the charge on copper. And chloride is always -1. Cu, Cl. Again, Roman numeral's my charge on iron, so 3 plus. Oxygen is group 16, so -2. 2 irons. 3 oxygens. So far, so good. Barium bromide. Barium's in group 2, so +2. Bromine -1. Ba, Br, 2. Intro to nomenclature, we're going to review it more coming up. And we name acids. All acid structures have the same basic form, H plus an anion. And you use how many hydrogens you need to cancel. Hydrogens +1, so if your anion's -1, 1 of it. If your anion's -2, you need 2 hydrogens. And if your anion is -3, you need 3. It requires enough hydrogen to cancel the anion charge. So if an anion ends in IDE, so if it's right from the periodic table, you add the prefix hydro and change the ending to IC. HF, hydrofluoric. HYDROFLUORIC, acid, hydrofluoric acid. HBr, hydrobromic acid. I didn't use the example that I used to remember it in your packet, though. HCl, hydrochloric acid. That's the one I think of because it helps me remember when it's just H and an ion, hydro-whateveric acid. If an anion ends in ATE, so if I'm looking at oxygen, if I'm looking at an oxyacid, where there's oxygen in the anion, then I just change the ending to IC. I say that like it's so simple, but when we look at the spellings, you got to put a little bit of thought into it. HNO3, NO3 is nitrate, nitric acid. Good. Easy. Follows the pattern. H3PO4. That's the phosphate ion. So don't write this down. It should be phosphic acid, right? Phosphate, phosphic, like nitrate, nitric. It's not. It's phosphoric. Sulfuric keeps more of the word, too. Will I take points off if you misspell it? Maybe. But keep your eye out that it's not literally drop it and add IC. Sometimes you go back toward the name of the element a little more. So HNO3 nitric acid, H3PO4 phosphoric, PHOSPHORIC acid. If your anion ends in ITE, you do something similar to that, only you change the ending to OUS. So H2SO3 is sulfurous, SULFUROUS acid. And for that HClO2 coming from the chlorite ion, your chlorous, CHLOROUS acid. Good. Molecular nomenclature, remember, a binary molecular compound contains two nonmetals. Which one do I list first? The first one I see. The one farther to the left. As I say, the first one I see, right? Which one do I list first? So if I tell you two are in the compound, the one farther to the left. And I guess that's where I'm saying I see it first. You read left to right. I'm talking like boron and chlorine. Who gets listed first? Boron. It's further this way. It has to do with electronegativity, but in general, the one you see first, the one farthest to the left. The exception is oxygen, and only if it's with a halogen. So it would be like ClO3. You'd list the halogen first if it's with oxygen, even though oxygen is farther to the left. The ending of the second becomes IDE, and we'll see those in the review. Two ways you can count atoms, using those Greek prefixes. Those go with the subscript. Think about carbon dioxide. 1 carbon, 2 oxygens. Never use mono with the first, but the subscript corresponds to the prefix. CO2, carbon dioxide. CO, carbon monoxide. Ha. Remember, this is only with 2 nonmetals. If I'm using the stock system, I use a Roman numeral to do the same thing. Basically, you uncross your charges. Like we were doing with your cations, here with iron 3 oxide, the Roman numeral tells me the apparent charge of the first thing. So it's the Roman numeral that's given. If you look at the example in your packet, N2O5, oxygen's in group 16 or 6A and has a charge of -2. You look up the charge of the element to the right, and you use it to figure out the charge of the element to the left. Same idea as what we were doing here. So you would be nitrogen 5 oxide for that one. I have charts of those. Let's check those out with the practices more than anything else. This is magic. This is like game show magic. There's your practice here. Let's see what we've got. We've got some that are with prefixes, some with Roman numerals. Diphosphorus means P2. The prefix is the subscript on that element. Pentoxide, O, pent is 5. Where am I getting these? The packet has the chart. Good. Nitrogen 4 oxide. This means nitrogen acts like its charge is 4+. Oxygen has a 2- charge, so I need 2 oxygens. 2 times -2 is -4. Cancel +4. Oxygen difluoride. No prefix on oxygen, so it's just O. Di is 2. OF2. Boron 3 bromide. Boron's going to act like its charge is 3+. Bromine's 1-. B. Br3. Tetra is 4. Like the game Tetris. If you know the game Tetris, old school Nintendo, like 90s Nintendo, every shape you used had 4 blocks because tetra is 4. So there's tetraphosphorus. Deca is 10. So I have 10 sulfurs with it. Almost done. Charge on sulfurs acting like 6. Fluorine's -1. 1-. SF6. Carbon, no prefix, no Roman numeral, I'll just go with carbon. Tetra is 4. CCl4. Roman numeral. Hydrogen's +1. 1+. I keep doing that. Oxygen's -2. H. I need 2 of those. Looky. Hydrogen 1 oxide is water. Cool. I could also call water, look at this, dihydrogen monoxide. Working backward. All this packet was to do was to introduce you to the naming ideas. The practice you're going to work on is going to go through some more. Make sure you check out my answers here. And make sure that you look through the section when we go through review. Make sure you pay attention. Nomenclature is a big idea. and I want you to review it well. That's the last section of True Notes for your summer assignment. The rest will be going over problems and posting answers to the packet questions. Thanks, and see ya.